Welcome to this explainer. Let's be real for a second. The Cambridge physics exams can often feel like a relentless enemy, constantly trying to catch you out. But here's the thing. When you are pushed out of your comfort zone, you push back. And you push back with absolutely perfect, unshakable answers. Consider this your John Wick training montage for the Cambridge exams. Today we are diving deep into a tactical masterclass on conquering physics questions, specifically zeroing in on vectors. And look, whether you're tackling the classic 0625 syllabus, combined sciences like 0651 or 0652, the O-level 5054, or even gearing up for A-level 9702, the rules of the game remain exactly the same. We aren't just going to sit here and passively reread a textbook. No way. We are looking at exactly how vector concepts appear in real physical systems, in your intense calculations, and crucially, in the actual exam questions that dictate your final grade. If you want to move beyond just mindlessly memorizing definitions and actually understand how to structure an examiner-proof answer, you are in exactly the right place. Let's get started.
Right out of the gate, I want you to ask yourself this question. What physical effect actually depends on understanding vectors before we even use the formal language of physics? To answer that, let me introduce you to two types of students we see every single year. First, we have Alex. Alex overloads every answer with raw physics but completely lacks analysis. Then there's Sam. Sam rushes under the pressure of the clock and totally misses the command word requirements. We're using an application-first approach today so you don't make Alex or Sam's mistakes. Why? Because the absolute best way to understand vectors isn't to just stare at arrows on a page. It's to see how those arrows predict real, tangible physical outcomes. If you can deeply understand the physical effect first, like why a plane gets blown off course by a crosswind, you become far less dependent on memorized wording. You will actually be able to logically reason your way through those incredibly tricky, unfamiliar exam questions that Cambridge loves to throw at you.
Okay, here is our strategic blueprint for today's session. We will start by identifying and completely avoiding the common pitfalls in the vector trap. Then, we are going to break down a four-step framework known as the SAFE method, which is basically your ultimate defense mechanism. After that, we'll build an unbreakable chain of cause and effect, explore real-world vectors to ground our knowledge, and finally end with memory prompts to lock it all in permanently.
Let's move straight into Section 1, the vector trap. This is where we analyze the battlefield and see exactly where students are bleeding marks unnecessarily. Imagine a split screen right now. On one side, we have Alex, sweating over a vector forces question. On the other side, Sam, furiously scribbling away. Both of them are about to fall right into the trap.
Take a look at this. On the left side, we have Alex's classic mistake, a massive flaw we see under exam pressure, is writing down a perfectly correct formula, but completely failing to explain the variables in the context of the question. Let's say it's about momentum. Alex writes P equals mv and moves on. The examiner's red pen comes out and Alex gets maybe 1 mark out of 3. Examiners see this all the time. Dropping isolated facts or naked formulas won't get you full marks because it doesn't prove you actually understand the physics. The true mastery fix? Look at the right side, explicitly explaining what each variable means physically. You have to tell the examiner the physical story behind the math. You need to say that m represents the specific mass of the colliding cart, and v is its vector velocity, meaning direction is absolutely critical to the outcome of the collision. That is how you bulletproof your answer.
And here is Sam's major pitfall. Sam quotes a process perfectly from memory, but provides absolutely no context. For example, reciting the rule for finding a resultant force using a parallelogram, but entirely forgetting to apply it to the specific crane or the ship mentioned in the question prompt. To secure top marks, you must link the process directly to a physical effect. You cannot just give an abstract example without showing exactly why it follows from the underlying physics of the scenario in front of you. If you memorize the wording without the reasoning, those high-level exam questions will catch you out every single time. They are specifically designed to penalize rote memorization and reward genuine comprehension.
Moving on to Section 2, the SAFE method. This is where we reveal the strategy to counteract those exact traps. It is all about decoding command words and applying a rigid, dependable structure. Before we continue and dive into this framework, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, let's get into the mechanics of building a perfect answer. Top students do not just write, they architect their answers. They use what we call the Peel framework, tailored for physics, which matches up perfectly with our 4-step SAFE method.
Step 1 is the point, or the definition. Identify the core vector quantity or the phenomenon immediately. Step 2 is the evidence, or the relationship. State the symbolic relationship, the formula, or the vector rule involved. Step 3 is the explanation. This is where you explain the underlying physics of what is actually happening. Why does this rule apply? Step 4 is the link or the application. Connect your explanation directly back to the observation, the experiment, or the real device mentioned in the prompt. This sequence is absolutely critical in IGCSE-style physics because the absolute best answers demonstrate both deep theoretical understanding and practical, real-world application. Don't skip a single one of these steps if you want that top grade.
Section 3. Cause and effect. This is where the transformation happens. We are going to take those red pen marks that Alex and Sam got, and we are going to turn them into solid green check marks by implementing a flawless logical chain. Just look at this quote straight from our syllabus source material. Insist on cause and effect rather than isolated facts. This is literally everything you need to know about the examiner's mindset. When you are writing your answer, you should move gradually from everyday language to precise, razor-sharp physics vocabulary. Let's rewrite Alex and Sam's flawed answers right now. Instead of just stating that an object moves in a circle, you build the chain. You state that because velocity is a vector, a continuous change in direction means a continuous change in velocity. A change in velocity means an acceleration is occurring, and according to Newton's laws, if there's an acceleration, there must be a resultant force acting toward the center. Do you see what we did there? We started with a concrete example, introduced our physics terms one by one, and showed the examiner exactly how one event triggers the next. It's a compelling narrative where the physics is the main character making things happen. That is your physics success blueprint.
Now let's apply this exact blueprint to something that completely trips up a lot of students: vector graphs, particularly velocity time graphs. If your exam question involves graphs, do not just describe the picture. Examiners hate it when you just say, the line goes up and then the line goes down. You must explain what the visual elements mean in the actual physical world. What does the slope physically represent? It's the acceleration. What does the area under the curve physically represent? Because velocity is a vector, that area represents displacement, not just distance. What does a change in direction, like the line crossing the x-axis, or the overall shape tell us about the real-world object? It means the object literally stopped and reversed its direction of travel. Always translate the ink on the page back into gritty physical reality.
Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to at acetheexams_IGSE and turn on all notifications so you never miss our weekly exam strategy sessions. All right, let's jump straight into Section 4, Real-World Vectors. It's time for our interactive workshop.
Vectors are literally everywhere. They are the absolute foundation of engineering and construction. Think about resolving tension forces in the cables of a suspension bridge. They keep us secure in transport and safety, calculating the exact braking distance of a car by balancing the vector of forward momentum with the opposing vector of friction. They manage our energy systems, drive medical technology, and allow us to build global communication networks. Now, for this interactive workshop, I want you to be highly active. Let's do Challenge 1, Data Scan. Imagine a complex data table showing the velocities of 2 colliding objects. You have 60 seconds in an exam. Can you extract the core trend? The trend is that total momentum before equals total momentum after, accounting for vector directions. Challenge 2, Find the flaw. Listen to this sentence. The car traveled at 20 meters per second around the track, so its velocity was constant. Did you catch the flaw? The speed is constant, but because the direction is changing on a curved track, the vector velocity is constantly changing. Challenge 3, Speed Writing. You have 30 seconds to write one perfect peel paragraph explaining why a skydiver reaches terminal velocity. Point: terminal velocity is a constant speed. Evidence: it occurs when air resistance balances weight. Explanation: because these two opposing vector forces are equal, the resultant force is 0, meaning acceleration is 0. Link: therefore, the skydiver falls at a constant maximum velocity. Boom! Full marks. For your exam, you should always be ready to pull out at least one real situation from this list and explain exactly why the vector physics helps us predict the outcome.
Incredible work on that workshop. Now we are entering our final stage, Section 5, Memory Prompts. This is all about the final system, summarizing everything we've learned into a cheat sheet that you can carry into the exam room in your mind.
So here's your complete physics answering system condensed into 4 prompts.
First, command word decoding. What is the core idea the examiner is asking for? Are they asking you to state, describe, or explain? Second, Peel framework application. What changes physically, and how do you structure that explanation logically? Third, what quantity or graph actually shows this change? And fourth, the time management matrix. Where is it used in real life, and have you allocated enough time to link it back to the specific application in the prompt? If you can run through these 4 specific steps aloud, actually speaking them out loud to yourself, for any vector topic during your revision, your knowledge is 100% secure. This system guarantees top marks because it forces you to think like an examiner. You are covering the theory, the math, the physical reality, and the application all in one go.
So I leave you with this final, ultimate test. Can you confidently answer those 4 prompts aloud before you walk into the exam room? Because students who implement these physics strategies see an average improvement of 2 full grade boundaries. But that only happens if you practice consistently. Here's your final reminder. Subscribe to our YouTube channel Ace the Exams at @aceexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @aceexams_IGCSE and click that bell. Don't let another exam pass you by while you settle for a lower grade than you deserve. Drop a comment below right now with your target grade for physics and the biggest challenge you are currently facing with vectors. Our team responds to every single comment to help you out. Take these strategies, apply the cause and effect chain, and transform yourself into a strategic problem solver. Like and share this explainer with a study partner who needs to see this. Ace the Exams. Your Cambridge success starts here.